Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. In this session we will discuss this Deek-Robot 100 volt 10 ampere panel meter. It also displays the watt, the power rating. It is a DC voltmeter, DC panel meter. We will see its features, its specifications, its connections, how we can make wiring, and we will check its operational check, and we will see its different measurements and different options, and we will check its calibration, and we will see dimensions to install on the panel if we want to install on some panel or like that, and we will see its sourcing, and we will see its price. Let's start. This Deek-Robot 10 ampere 100 volt, this panel meter can display, it can measure up to 100 volt in the top side, and here is the current rating. How much is the current? For power measurement, it will multiply voltage times current, and it will display the total consuming power to the load. The best thing that it have a calibration axis in the panel, so you can calibrate it very easily. It have a cool blue LCD display and backlight is here. Initially this panel meter is supplied in these three parts. One is the load cable, that is to monitor the current, power cable, and a sense line, voltage sense line. The best feature in this meter that it have a built-in shunt resistance. When we purchase current meters, ampere meters, we need some external shunt, but the best feature here that it have a built-in shunt, so we no need to use an external shunt and calibration issues. It have two connectors. First connector is used to power up. It have three wires. It is microcontroller based, so microcontroller and its LCD display is here. Two trim ports are provided here to provide the current adjustment and the voltage adjustment. And this is the load connector. We will connect this meter in series with the load. When we want to make connections, it is very simple to organize, very simple to connect. This is our meter. We have two wires here, black and red. And we have three wires here, 1, 2, 3. This one red and black. These two wires are to power up from some external supply that is not the same. We can connect to the same power supply if it is less than 12 volt. So we need 7 volt to 12 volt at these two wires. Red is positive and black is negative. Then we have white wire here, that is the voltage sense. We need an external power supply other than this, the power supply which is driving the load. So it is best way to use an external adapter, external power supply, external battery. We can use 9 volt battery, that is the best solution. We can power up with these two wires, positive and the ground. I will connect with this external 11 volt power supply, 11 volt, 12 volt we can connect. When we connect it, it is showing 0.0 volt, 0.05 ampere. This is calibration offset. So initially we will set it to 0 by adjusting this potentiometer. Now it is 0. When it is 0, 0, that means no offset error is present there. To make connections for the shunt resistance, we have a battery here which is driving some load, negative, positive. So negative of the battery terminal will connect it to the black line, that is here. So battery negative terminal will connect it to this one, and in the positive line, because in any ampere meter the current is required to flow from the shunt resistance, that is here. So it is in milliohm. It will not drop too much, so it will reduce just only in millivolts. We will check it. So the current will flow from the load resistance to the shunt and to the battery, and voltage dropped here will measured and it will display in the numeric form. How much current is flowing there, how much voltage. So when we want to test the voltage, so we will connect this positive line, white wire, to the battery positive terminal, which is being monitored, because we have to monitor the voltage from this source and we have to monitor the current flowing in the load. So both items are connected here. Let's make these connections. So this is positive line and this is the negative line. 11 volt. We can apply 11 volt, 12 volt. It is just to power on this panel. Now I have this load resistance. It is any resistive load, any inductive load, whatsoever. This is the negative terminal of the battery and this is the positive terminal. So negative terminal, as we discussed, it will connect it to the black wire. So here is the black wire. Powering up source, it is separate here. We connected the negative line to the black wire, as we discussed here. And we connected positive to the load, and the second side we will connect to the load second side. Any load, if we are using some fan, some resistive load, inductive load, whatsoever. Now we want to check the voltage, so we will connect to the input side, the battery terminal, that is which voltage are connected to the load, which are here. So we will connect. Now we connected the white wire, which is the sense line. So this wire is connected to the sense line where we are applying voltage, and after load the red wire is coming to this connector and black wire to the battery negative terminal. So here we apply 2.5 volt and it is measuring 2.8 volt. So we can adjust from the voltage calibration potentiometer. Unless it will show 2.5 volt. So it is 2.5 volt, the same. Now it is calibrated. I applied 2.5 volt to a 6.81 ohm resistance. It is showing 3.67 ampere. Let's check it. So we will increase slightly. So the both meters are now working same. This time I adjusted the current to calibrate with the same. So it is 0.35 and it is 0.35. I applied 2.5 volt to a 6.8 ohm resistance. The current should be 0.367. So the current is 0.37 ampere. That is good. And if we check 2.5 volt multiply by 3.37, so it is 0.92 watt. So it is just only calculating the power based on this voltage value and this current value. If this video is good, hit the like button. If you have not subscribed my channel until now, please subscribe it. If I will increase the volts, same time it is giving the power rating. The amperes are also increasing. It can measure up to 100 volt and 10 ampere. 100 times 10, it will display 1000 watt. So we can monitor it, we can install in some panel or like that. If we see its dimensions, it is around 3.1 inch. And if you want to make hole in the board, in the panel, so it is around 2.75 inches, and in millimeter it will around 71.5 millimeter. To make a hole in this direction, it is 1.5 inches, and we can say it is around 39 millimeter. It have collars to lock on the panel. We will push in some metallic panel and it will display very nicely. And if we see this fitting, it is around 0.6 inch. And if we see its clearance, so it needs around 1.5 inch in this portion. If we have a clearance in the panel 1.5 inch, so it will be installed very easily. It have a shunt resistance here. Now we will check how much it will drop the voltage. If I am applying 10 volt, the shunt resistance is dropping 8 millivolts. So the supply provided to the load will not drop too much, 8 millivolts in case of 10 volts. It is really excellent tool. And if we discuss its price, I purchased it online from Aziz Electronics from Pakistan. In Pakistani currency it is 1,600. You can say it is around $8.7 with the shipping charges. I purchased it from Dra's online application. I am not promoting any product, I am just sharing my practical experience. So I hope so this video is informative. If it is informative, hit the like button. If you have any question, let me know in the comment box. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.